Okay, so for problem 6-7, you're given a spring and you're given two blocks, one of 5 kilograms and one on top of 3 kilograms, with the spring constant of 1,000 newtons per meter. So for part A, it says when the blocks are at rest, how much is the spring compressed from its original length? So all you have to do for this is use the formula for spring force, which is F equals K delta X. Solve for X, which in this case is mg for the F and K for the spring constant. And then all you have to do is plug in your values, and then you get the answer, which is delta X, which equals 0.078 meters. So now the blocks are pushed down and they're oscillating. So for part B, it asks you to determine the frequency of the oscillation. So all you have to do is use the formula for frequency, which in this case, since it's for a spring, it's going to be 1 over 2 pi times the square root of k over m. So now all you have to do is plug in your values. So you have 1 over 2 pi, 1,000 for the spring constant, and 8 kilograms for the combined mass. Solve, and then you get your frequency is 1.8 times s to the negative 1. For part C, it says determine the magnitude of the maximum acceleration that the blocks can attain and still remain in contact at all times. And if you think about it logically, when this is going to be moving down, the spring is going to pull the 5 kilogram block down, and it's also going to be under the force of gravity. And so if it goes any faster than that, this block up here won't be able to fall fast enough, so they will lose contact. So therefore the maximum acceleration has to be gravity, which is 9.8 meters per second squared. Now part D asks, how far can the spring be compressed beyond the compression in part A without causing the blocks to exceed the acceleration value in part C? So to find the maximum acceleration, you first need to know the maximum distance it's going to be oscillating, which in this case is going to be the amplitude. So for the maximum acceleration, we're again going to be using the spring force. So A max equals the spring constant times the amplitude over mass. So now we can solve for the amplitude, which is going to be mass times maximum acceleration over k. Plug in your values that you're given. We have 8 kilogram mass combined, 9.8 meters per second, which we found for the maximum acceleration and the spring constant. And when you solve for that, acceleration is 0.078 meters. Now for part E, it says determine the maximum speed of the blocks if the spring is compressed with the distance found in part D. So we're going to use the law of conservation of energy. So maximum kinetic energy is going to equal maximum potential energy. And in this case, maximum kinetic energy is 1/2 m, and it's going to be the maximum velocity squared. And then for the potential maximum, it's going to be 1/2 k times a, which is the amplitude squared. So now we can set the two equal to each other. The 1/2s will cancel out. So then you're going to be left with the Vmax squared is going to be Ka squared over m. Plug in your values for Vmax, so you have 1,000.078, which we found previously in 8 kilograms, and when you solve, you get the maximum velocity is 0.87 meters per second.